I'll share my experience. I have published, I think, more than 15 papers using these techniques. So this is our curriculum, right? Mann-Kendall method, autocorrelation function, innovative trend analysis, modified Mann-Kendall test, and Rho algorithm. Yesterday, one paper published from Arabian Geoscience, this one, investigation spatio-temporal variability of meteorological drought, Luni River Basin, Rajasthan, India. It was published yesterday using the same technique, innovative trend analysis, Mann-Kendall test. Okay, so I hope you can also publish lots of paper using this technique. So I'll share my experience. I'll share my practical experience, because what happens if you use time series data, you may face some problem. This is called practical problem. Sometimes you may face to enhance this data. Sometimes you may face to calculate missing data. So I'll share everything from A to Z. Okay. So in this workshop, basically I'll use 3 software. One is MS Excel, another is SPSS, another is R. So R is open source, so everybody can install it. I'll show how can install. And SPSS paid version, so you have to purchase it, or you can install trial version. I'll share how can you do it. Let's start to discuss advancement in trend analysis for time series dataset. You may aware about the time series dataset. Sometimes it's a common question. What do you mean by time series? What should be the ideal length of time series? If you're working with groundwater data, if you're working with climate-based data, then your time series dataset should be at least 30 to 35 years. There's no such strict rules, but you should try at least 30 to 35 time series data to conduct any trend analysis. Now, in literature, you can find lots of methods for trend analysis for time series dataset. But most commonly used method and most popular method is Mann-Kendall test. Mann and Kendall, 1955 and 1945, independently given this method. After that, this method, Mann and Kendall, their algorithm used in many cases, not only climate-based analysis, also in many time series analysis, this method used. But problem is autocorrelation problem. So that's why another method, modified Mann-Kendall test, Hammett and Rho, 1998, Hammett and Rho proposed modified version of Mann-Kendall test. So I'll share original version of Mann-Kendall test and modified version of Mann-Kendall test. But problems still exist, because in case of Mann-Kendall or modified Mann-Kendall test, there is some assumption like normality distribution of data set. Also, Mann-Kendall or modified Mann-Kendall test is a monotonic trend. I'll explain what is monotonic trend, what is non-monotonic trend, obviously, and I'll share the original paper of this method. Okay, so if you considered monotonic trend, so what are the hidden trend? So using innovative trend analysis, we can find hidden trend, we can find sub trend also. Okay, so I'll share everything. So already you know, I am Dr.JayantaDas, Assistant Professor of Rampurhat College. This is my WhatsApp number and calling number 2. You can contact me anytime if you face any difficulties. And I hope this conversation will be two-way. You can stop me anytime. You can ask me any question if you face any difficulties, because it's a workshop, it's not lecture. So I hope you will also practice using my data. I'll upload also data in here in chat box. I hope I can upload here. Okay, I'll share the data set also. So this is the today's topic, quality control. Most important part of any time series data, basically station-based data, then missing data calculation, convert data. Probably you will get data in daily basis. You have to convert it into monthly or seasonal or annual. Then trend analysis method in defined algorithms, Spearman Rho or ITA, MK, MMK. Then how we can visualize this data, how we can prepare our table for publication, right? So let's start about the quality control of time series data. This is the most important part. If you get some station data, then you can face this problem, because sometimes you can find typographic error. Sometimes you can find, instead of 0, you can find this O. And your software, your Excel or any software didn't recognize this, what is 0 and difference between 0 and O. So we have to identify this problem. And in case also temperature, maximum temperature and mean temperature. So we know mean temperature always less than maximum temperature. So we have to identify, or we have to make sure that mean temperature less than maximum temperature, and precipitation always more than 0. It's never negative. So we have to confirm it. So, and I have published one paper, meteorological drought analysis using standardized precipitation index over Luni Basin. And I use one tool, ClimText tool. It is freely available and it is very handy to use. You can easily use it, but you can do it in manually. I'll share how we can use it. Okay, I'm talking about this paper, meteorological drought analysis using standardized precipitation index over Luni River Basin. So here you can find data collection and inference of model parameter. You can find here quality of the data. We should maintain quality of our data. Okay. Now here I have some data, like here monthly data. I have collected this monthly data from Government of Rajasthan website, Water Resource Portal website. Okay, is it visible? Now see, we have to check first everything is okay or not. I'll use this data. Okay, some question is in chat box. So yes, here some station data, Asme, Bhinai, Jawa. This data are freely available. This is a daily data. I have converted this daily data into monthly data. Also, I'll show you how we can do it. So this is data from 1957 to 2019. Okay, let me share in your chat box. Then you can work on it. So please check it on chat box. I have shared 2 data set. Download it. One daily data, another monthly data. Did you get this data?
No, sir.
Yes, got it.
Okay, please download it. This is monthly data. This is freely available from Rajasthan Government of Rajasthan website, water portal, probably water portal website. So see what I have found here. There is some NM not available. Data is not available. Here that's been missing data. We have to check one by one. If we considered first one station like Pishangan, okay, Control A, open a new Excel. No need this name, because I'll save it by this name, Pishangan. So we can easily rename it. This is a station name. Okay. Now check here NA. NA mean not available. That's the missing data. Okay. So we have to check how many NA is there. Okay. We can easily check it if we click here and go to sort and filter and click on filter button. See here, any missing data exists here. Smallest to largest, click on largest to smallest. No. Then February. No. Then March. No. April. No. Then June. See here missing data NA. Then here missing data NA. Here missing data NA. Largest missing data NA. Plus here see this symbol. This is also missing data, but it's different. Okay. NA, NA. Okay. So what we do now, again, smallest to largest. So 1957 to 2019 filter. Now we can replace this. Click on replace button and copy this. Find what? And it's null. Replace all. 10 replace there. And also this symbol. Copy this symbol and place here. Replace null. Make two replacement. So now we have checked our quality. Now we have to calculate missing data. We can calculate missing data by using many methods, but one popular method, multiple imputation method. So I'll discuss it. Multiple imputation method to calculate missing data. So I'll use here SPSS software. You may aware about imputation. Imputation means actually calculation. So multiple imputation is a general approach to the problem of missing data. You can find another technique, single imputation method. It's a multiple imputation method because it's calculate or it's allow for the uncertainty about the missing data by creating several different plausible imputed data set. So several different plausible imputed data set, that's why it's called multiple imputation. I have used this technique in this paper. You can refer my paper if you use this technique. I'll share also my paper. So I'll share how we can calculate it or how we can calculate it in SPSS software very easily. Now we have to save it. It's year, right? It's year. Just save it in Excel file or CG file. It does not matter. Computer, data section. So live practice. You can ask me any question if you face any difficulties. Vishangan. Save it. You can also use ClimDex software. It is freely available. Now open SPSS software, IBM SPSS Statistics 25. If you don't have this software, just go to Google and search SPSS download. Then you can find your vendor. Various vendors are available. You can download it. And Google search here IBM. IBM SPSS download. This link, download IBM SPSS statistics. You can download trial version, but it is available only 15 days. Okay. It is only available for 15 days. A free trial version is available. You can directly link on that. You can directly download this try SPSS statistics at no cost. Okay. Then you can use it. Or if you want to purchase it, then you have to click here. Then buy from IBM vendors. You have to click there. There's a lots of vendor there. I think this vendor provide less amount. Purchase for 6 months, $49. So you can purchase from there. So let's try it here in SPSS. We can easily upload direct Excel file in SPSS software. Go to here, file, and open it. Open data. So now we have to go our destination folder like personal D, 1 day workshop, live practice. Now see, nothing is there because here file type. We have to change this file type. We have to change to file type Excel. Now this one, Excel. Open it. Now see, this is a validation. Nothing to do, just click on OK. Now here our data, year, January, February, March, April, May, June to December. Go to variable view. Now see all are scale, but this one nominal. We have to change to scale. December also scale. Okay. You may add about nominal, ordinal, or scale. So now go to analysis tab. Here directly go to multiple imputation. You can see about analysis pattern. An overview of analysis patterns. Select first one, January. Press shift button and click December and see this button. Click on that. Okay. Nothing to do. Default, it is 10%. Minimum percentage missing for variable to display 10%. Basically, in time series data analysis, less than 5% missing data is allowed. But in some software, it's very sensitive. We have to calculate missing data because missing data is not allowed here in software. So we have to calculate first our missing data. Now see our missing data. In this case, in overall, if we check it, incomplete data, that's 1.720. So in this station, incomplete data set 1.720 only. That's been less than 2%. Okay, less than 2%. If we see my publication, I have written in every paper, supposing here one interesting paper published from Environment Development and Sustainability, exploring driving forces for large-scale unsustainable groundwater development for irrigation in Lower Ganga River Basin. Basically, we have used here groundwater data, groundwater depth data, okay, and we have used here only Mann-Kendall Test and innovative terrain analysis for seeing groundwater development is sustainable or unsustainable, because it's a irrigation-based area. See here in data section, study area, then data. We have to clarify it. This study discarded a dark oil with long missing record, because we have to remove long missing record, because it is a common practice missing data in case of station data, in case of observation data. Okay, so we have to mention it. If you check others paper, it was also published from a very good journal, Theoretical and Applied Climatology. It is also very good journal. See here, data we have mentioned here. You have to mention, see, the missing data in the time series observed less than 1%, which has been calculated using multiple imputation method. So you have to calculate it. If data set has any missing record, then you have to calculate it. So you can use this technique, multiple imputation method. Now, here, according to this analysis, it is less than 2%. You can write less than 2%, or you can combine it to all station. Now you can export it like this way. There's others is also there, but no need. Only we need this overall summary of missing data. It's a variable view. 6 variable, there is no missing value. 6 variable, there is a missing value. Okay. This is a cases. How many cases is missing data? 6 cases. Okay. So we can export it, just right click over there and export. We can export it, right? Like I want to export it personal on the workshop live practice here. Pattern. Missing data. Click it OK. So now we can easily calculate missing data by calculating using multiple imputation method. This one, impute missing data value. So here variable in model. So we have to select January to December. Then imputation. That's mean iteration type, based the repetition of process. You can increase or decrease, but in default, SPSS is 5. Create a new dataset. You can create a new dataset. Yes, I want to create a new dataset. So you can provide one name, suppose, or you can write a new data file. I want to give one name, create new data. Okay. Pishangon. Okay, now go to this method section here. See, there's many methods there. It's a automatic. So here in case of custom, you can see MC method. That's in Monte Carlo Markov chain model. Monte Carlo Markov chain model is calculated basically in arbitrary pattern. But in case of monotone pattern, if it is monotone pattern, then you should select a monotone pattern. Also, there is an option, it's a linear regression or predictive mean matching P or PMM. But in case of SPSS, it's a very smart software, so we can select automatic. So it is automatically select which method is applicable for our data. Okay. So now constraint, see here scan data, here a variable name, here percent of missing. If we scan this data, just click over there, then it will be scanned here. Okay, percent of missing, observed mean, observed minimum value, observed maximum value. Now variable and role. Now how they can impute? Impute, see there is a method, impute, use as predictor, impute only, use as predictor only. But we want impute as a predictor. Now minimum value and maximum value, you can select here minimum value and maximum value, because in case of rainfall, it should be more than 0. So our minimum value should be 0. So we have to assign here minimum value 0 in order to give here maximum value. So we have to assign minimum value 0. You can do another thing. You can, instead of 0, you can check here observed mean. Suppose January, February, March, minimum value 0, 0, 0. June also 0. All are 0. So no issue. We can use. If it is in case of March, if minimum value 10, then you can assign here 10. Okay. Now output, imputation model, descriptive statistics, you should click on that. Descriptive statistics for a variable with imputed value, and create iteration history. Okay, you have to assign another name, history. I can give you any name, doesn't matter, and just click on OK. Okay, now see, imputation specification, number of imputation 5. So maximum percentage of missing value 100%. So already it has calculated. Here our new data, create new data set. If you open here, new data set, see, this is the original data set. Here, check it here, original data set. We can find a missing record, this one, missing record. If you change it like iteration 1, you can see already calculated missing data. But in case of iteration 2, it is defined. In case of iteration 3, definitely it will be defined. 4, definitely is defined. 5, it is also defined. Now, what do you want? What to do? Which iteration you will use for your time series data analysis? For this purpose, you have to calculate other statistics like t-test, like other tests for selecting your data set, or you can select iteration 1. Okay, because there is a nominal missing value only less than 2%, so you can select iteration 1. Then you can export this data set, or you can use this data set for calculation, other calculation. Okay, now here analysis stuff. Okay, if you want to calculate, already we have calculated this missing record. Okay, now we can use our other analysis. Okay, if you have any question, any doubt, then you can ask. We can use this data for our time series 10 analysis. If you have any question, then you can ask. Otherwise, I will move forward for our next analysis. No question. So next one, how we can convert your data. Suppose you will get daily data. So how you can convert? You can easily convert it using pivot table in Microsoft Excel. So already I have sent you the data set, right? So here, daily data. You can easily convert it into monthly, into annually, or into quarterly or seasonal. Okay, like any cell, anywhere, only one cell. Okay, go to insert button here in Excel. Then go to a pivot table, right? Then this pop-up will be open, and now see it is selected, right? Now see new worksheet. If you want to create a new worksheet, then click on OK. Now see, then this pop-up will be open. Now click on date. If you click here, see it's only shows date. So, but we want month, we want quarter, or we want annual. We have to group it. How we can do it? Just click over there and make a group. Here the group. Okay. Now see grouping option. Select month, select quarters, select year, and take it OK. Now here year, quarter, and date. Now there's a 4 option: one filter, column, row, and values. Okay, so it's a row and it's a column. So I need column. So date in column, that's in month. Okay, and no need quarter. So it's again total, mean annual. So now suppose I need maximum temperature. Okay, now see in values, it's automatically in default, Excel is automatically sum, but we need, in case of temperatures, we need average. So we can easily setting in value field setting average. Now it is average value. It's a monthly average value from 1979 to 2014. Now we can copy and paste anywhere. Okay. It's a table format. So if we copy it, Control C. Right click and paste as a value only. Now, instead of row level, it's a year. So Tmax. Okay. Another. Uncheck it and click here mean temperature. Minimum temperature. Again, sum of minimum. So we have to change this value field setting. Average. Select it. Again, Control C. Right click. Year. This one Tmin. Again, instead of mean, precipitation. So precipitation should be sum. Precipitation mean accumulated value. So it should be sum. So Control C. Right click. Paste as value. Year. precipitation, right? This way, we can convert our monthly data. This is in Excel format. No, I think this is a CSV format. So we have to save it. Data. I have to save it in Excel. 97.3 workbook. Monthly. Any question? You can ask anytime. If you face any difficulties, you can ask anytime. Any question? Actually, I have been suffering severe fever since last three days. That's why it's very difficult to take 3 hour long session. But I'll try to give my best. Okay. So now, next one. Trend analysis Spearman Rho test. It's a very common technique. So we can easily calculate any trend analysis or any magnitude of trend or any detection of trend. Because in case of trend, let me draw one picture. So in case of time series data, time series, we can easily calculate here y-axis, this one y-axis and this one x-axis. So x-axis our time and y-axis our variable, right? So instead of this time, okay, it may be like this, that's been increasing trend. It may be like this, that's been decreasing trend, or it may be like this, there is a no trend. Okay, so we can find like no trend, another increasing trend, decreasing trend. Now, when you calculate any trend analysis, then definitely increasing no trend mean what? No trend mean obviously 0. And increasing trend mean positive value, decreasing trend mean negative value. And if you calculate anything, ideally 0 is not possible. So instead of increasing trend, we have to consider significant increasing trend. So significant increasing trend, right? Now, if you consider significant increasing trend, then you have to consider your confidence interval. So confidence interval, it should be 90%, it should, or it may be 99%. Okay. Confidence interval 90%, or you can consider both. You can check 90% confidence interval, you can check 95% confidence interval, 95%, 90%, or you can also consider in some cases 90%. Okay, so we have to check no trend. If it is significant, then we have to think it is increasing or decreasing. Otherwise, it is no trend, right? So increasing, not 10, significant increasing 10, and significant decreasing 10. We can categorize this way. Okay, so that's mean it's a two-way test. So Spearman Rho is a non-parametric test. Also, it is a two-way test, and we can consider this confidence interval using this SPSS software. So just we have prepare our data, daily to monthly data, this data. Okay, the precipitation data. So I'll use this data from this also annual data. Okay, just copy this. Year. Convert to number.
Your screen is not changed, sir.
Yo, sorry, just a minute. Now it is visible.
Yes, sir.
Okay. So convert to number. It's a year, January to December. Then it's grand total mean annual. And 0, 0, 0, 0, all is okay, but here the missing data. So we have to calculate our missing data. Already I have shown you how we can calculate our missing record by multiple imputation method using SPSS software. But in some cases, you can also calculate it by single imputation method. Single imputation mean what? Single imputation mean you can just consider the long-term record. You can calculate the average, okay, or average record like here. This is I, so I consider this I 2 is to I 36. Close this and drag it. So you can consider this. Now save it. I'll save it into one Excel file, or you can save it in directly in CSV file, CSV comma delimited station data. Yes. Close this data set. Okay. Now go to file and here open. And data. Now we have to change again here file type, this time CSV. Here station data CSV, select it and open it. Okay, it's generated data. Okay, next. It's a delimited data, that's why it asks some question. It's okay. Now finish. Here are data year, January to December up to annual. All data here. Okay, 2 questions in chat box. Venkatesh asks one question. Shati Kiran, how can we categorize significant increasing, significant decreasing if there is any base value? Yes, ma'am, there is a base value. Okay, I'll share. There's a defined base value. For defined statistical method for jet statistics, significant if you consider 95% significant interval, then p-value, that we have to consider p-value. Okay, if you consider 95% confidence interval, that's mean we have to consider p-value 0.05. Okay, and jet statistics should be more than 1.95. Okay, so I'll show you how we can categorize it. Okay, then another thing, can you please show how to calculate missing value using ClimText, which you have already mentioned in this workshop? Yeah, Venkatesh, I can show, but the problem is that I didn't download this ClimText software. I have used it in my research. ClimText software is so open source, we can easily use it. And also nowadays, another software is very handy to use, ArcGIS. Okay, you can easily use ArcGIS software. So today probably is not possible to show, but definitely I'll make one tutorial and I'll upload it in my YouTube channel, so you can do it very easily. Okay, ArcGIS software. I think it will be ArcGIS. This is one package called ArcGIS. Okay, so now go to analysis. Then here we have to calculate correlate, then bivariate, then select. We have to select from year because our X mean year, Y mean January, February, and annual. So we have to select also year to annual. Page shift button, then select first one and last one and check it here. Now correlation coefficient time, I want to calculate Spearman, select it. So it should be two-tail test. Okay, and there's the option flag significant correlate. So it automatically flag it. There's any significant or not significant. Then here option, various statistical option, no need this calculation. Also style, no need also. Just click on OK button. So here our table, correlation. So just click it, export this data. Just change this name. Just change this name here. Spearman Rho. And click it OK. I have published one paper using this method, Spearman Rho. You can refer this paper. It was published from Motion journal. I think it is very good journal in India. Motion variability and trends of rainfall using non-parametric approach is case study of semi-arid area. So here you can find the methodology. Calculation serial dependency. I think we have used here. Yes, here. Spearman Rho test. Okay. If you use this technique, you can refer my paper. So now check it. Already done. Live practice, Spearman Rho. Unmask it. So no need other thing. We need only this. We need only this data. So you can delete all. Okay, no, because there are some. Okay, here. Unmask it first. No need this correlation matrix. We need correlation with year to others. Here, Spearman Rho year correlation. Okay, that's one year to year. And this called this on year to January month. And this called year to February month. This called year to March month. And a question in chat box. Okay, let's check. Okay, Sam, surely, organizers surely share this recorded session. I hope. So here's Spearman Rho. Sam also published one paper, no? One paper from current science using this Mann-Kendall and modified Mann-Kendall test. So it's a very good journal, I think. Sam, are you hearing?
Yes, sir. Yes, sir.
Can you say about your journey about current science, about using this Mann-Kendall and
Yes,
modified?
sir. I learned that technique from your YouTube channel, the Innovative 10 analysis. The Mann-Kendall test I already knew, and I compared the two methods, and it is published by Current Science.
Oh, great journey. Actually, method is not matter. Matter is your thinking. Yeah, you have to find out research gap. Okay.
Yes, sir. Yes, sir.
Then you can publish. Otherwise, if you use new model like SPM or support vector or extreme boosting or other machine learning method, you cannot publish if you use a known area. You have to
Yes, sir.
find
Yes, sir.
out your research gap. You have to find out the nobility of your research. Okay.
Yes, sir. I learned this thing from your workshops.
Thank you.
I have attended all your workshops, you know.
You have joined all of my workshop. Yeah, I know.
Yes, sir. Yes, sir.
Thank you.
Thank you. And it is always nice to learn from you.
Yeah, thank you. I always try to simplify. How can simplify our research? Actually, research is very interesting. Research is very easy. So we have to understand basic thing. I know many of you are aware about this methodology, but I'm trying to show everything. Okay, because some of maybe new in this field. That's why. So see now, Michati ma'am asks about significant level. How can we categorize decreasing 10, increasing 10? Now, ma'am, see here the correlation in case of January. See here correlation coefficient minus 0.216. So if you see this, it's a minus, that's when negative. So it's a decreasing trend, negative trend or decreasing trend. Now, see here significant or two tail, that's when it's a p-value. So p-value 0.213. So definitely it's a non-significant decreasing trend. So you can categorize like this way: non-significant decreasing trend, significant decreasing trend, or you can categorize just simple T like no 10. You can consider it in no 10 because it's not significant at 95% or 99% significant level. So you can consider it instead of it is negative, but you can consider it as a no 10. Okay, because it is not significant. Value here 0.213. So another, in case of February correlation coefficient, it is also not significant. Same result we have found. In case of this, it is also not significant. Okay, I think there is no significant. But here, see, this is a significant trend. Correlation is a positive. Okay, 0.354 positive. It's a 95% confidence interval because see this significant p-value 0.034. If p-value less than 0.05, then it is significant, at 95% confidence interval, or if it is less than 0.01, then it is 99% confidence interval. So you can categorize like this way. Significant increasing trend at 95% confidence interval, significant increasing trend at 99% confidence interval, like this way also. Then you can easily map it. You can easily show spatial using spatial technique like GIS. Another correlation, it is also significant. September was significant. It is also increasing 10. Here also increasing 10, 95% confidence interval. Okay, so we have found 3 increasing 10, but in case of annual, it is not significant, but positive. So we can say 36 years rainfall, it is a increasing tendency of rainfall. Ratna ma'am asks how trend and significant trend are defined from each other, how to understand difference between these two statistically. Yes, trend, if we draw any plot, let me show. Here are station data. If we draw any plot, like here, these are x-axis and it is y-axis. Okay, select it and go to insert button here. Sorry. So now line plot. If we draw on line plot, we have to change it, this data, select data. Now select, unselect it here. We can directly change it, but we can remove it also from here and edit this data. Label mean year. No, we have to label it from here. Okay, and click it OK. There's one missing record, right? Everest. Always use multiple imputation methods rather any other technique. And this is only for demonstration purpose. So this is January month, x-axis and y-axis. If we draw any trend line, instead of January, if we considered monsoon month, then it will be much better. So let's change it. Add data. August. Up to here. So now if you draw here on 10 line, we can easily draw 10 line, add 10 line. See this 10 line. So we can display here equation or display R square value, display equation also. See, this is a linear regression method. So if we consider this linear regression method, it is also positive. It's also positive. If we consider it in August month, our result in here, this is also positive. Positive record, right? Another question is there. Yeah. Ratnakumar. Okay. How significant and dependence? Okay. So definitely there's a trend. Okay. There's a trend, but it is increasing or decreasing. We can't say. How we can say? Because here, if we consider it, see this one, this line, this is increasing. Again, it is decreasing. Again, it is increasing. Again, decreasing. There's a haphazard trend. Again, decreasing. Again, increasing. So overall, how we can decide it is increasing or decreasing? This is the question. So that's why we have to consider it only on a certain level of confidence interval. If it is statistically significant, then we can say it is a trend, it is a specific trend. It may be negative, it may be positive. If it is negative, then it's a decreasing trend. If it is positive, then it's an increasing trend, right? Otherwise, we have to say there is a no trend. If we consider this month, then August month, this is a no trend. But here, actually, this is a positive. But it is not statistically significant. That's why we can say it is a statistically not significant. So we can consider it our trend like this way. One, no trend.
Excuse me, sir.
Yes.
Sir, I understood that first we are confirming whether it is a positive trend or negative trend. Up to that, I am able to understand. But afterwards, the positive trend is significant or not? What does it special? What does it mean?
Significant or not, you have to check it using a p-value.
No, that is okay, sir. If p value is above this, we are saying it is significant. What does it exactly statistically means, or technically it means? There is a
Voice
trend,
is not
positive
clear.
trend is there. Sorry, there is a trend, and that trend is monotonic, either positive or negative. That much I am able to understand. But
Yeah.
afterwards, if that is crossing some particular p-value based on the confidence interval, we are saying it is significant. What does technically it mean?
If it is significant, that's mean we already we have considered it was significant. Suppose you have considered 95% confidence interval, right? That's mean in 95% cases, it is a increasing trend or it is a decreasing trend. And it may be error in 5% cases. We have considered 5% error. Okay. 95% confidence mean we have confident about 95%, but there is a chances error 5%.
Oh, uncertainty is 5%.
Yeah. So that's why p-value less than 0.05, it's a proportional case. If you consider proportional, that's means 0.05. If you consider 100% percentile, then it will be 5%. Right? So we can categorize. One of partition also asks about how we can categorize. So we can categorize like this. No trend. If we calculate multiple station, it's only one station. So if we calculate multiple station, then we can say how many station falls in no trend. Okay, how many station falls in? It will be better to show my published paper, I think. How I have arranged this, like already. Exploring. I have published another paper from Elsevier, Challenges of Sustainable Groundwater Management for Large-Scale Irrigation under Changing Climate in Lower Ganga River Basin. Actually, we have used in two paper, in same data in two paper, but in different way. Here we have used only one technique, Mann-Kendall Test. See, here we have prepared our table like this way. 95% confidence level. It's a 95%, 99% confidence, 95%, 90%, and insignificant. It's an increasing trend. Okay. In case of decreasing, also we have considered 99, 95, 90, and insignificant. Okay. So we can now see number of observed well. We have considered 572. Then out of 572, here 128 increasing, 99% increasing, 78, 95, 90, 41. So we can say how many percentage of oil experience increasing trend of groundwater depth. Right. So we can easily interpret it. We can visualize it in map. See, we have prepared this map. Just statistics. Significant decreasing trend, non-significant decreasing trend, non-significant increasing trend, significant increasing trend. So then we can prepare this map. Right. Similarly, we can use this Spearman Rho to prepare this table. Okay.
Sir, one associate question, sir. Sir, what exactly the difference between the trend in the data and stationary? Stationary definition also says that if you are having the mean, that means variance or mean is changing, that's in data is not stationary. The trend also implies little bit of same statistical meaning. So how to differentiate these two? Because in trend analysis, many times I have observed that the data should not be stationary.
Yeah.
Oh, these two are little bit
Yeah,
to understand. For me, it is time.
I'll discuss
Yes,
it.
sir.
I'll definitely discuss using ACF. How we can
Okay.
determine there is a serial dependency in our time series data set. We have to identify it. Okay. So
Yes, I am asking about stationarity. Sir. Serial dependency, stationarity, what is the same?
more or less similar approach.
Okay, sir.
We can
Okay.
find it. We can find it stationary,
Okay.
it's a stationary or serial dependency. It's a same approach. Okay, I'll
Okay, sir. Okay.
show you how we can determine it. We can determine it using ACF technique. Okay, autocorrelation.
Okay.
So I'll show you how we can determine it. Okay. So any question from this part up to Spearman Rho test? No. So I'll take 10-minute break. Actually, I need break because I'm suffering from fever. So that's why, sorry for your inconvenience, but I have to take 10-minute break just now. Okay. So let's start now. Another few technique. Already I have said I have published 15 papers using this technique. And Ratna Kumarji asks a very valid question. In case of time series data, there is a problem of stationary, or we call it serial independency data. That's why other technique already developed to overcome this problem. Okay, so most popular technique is that Mann-Kendall test. We all know it's a most popular method to detect trend for time series data. It is basically used to assess whether set of data value is increasing over a time or decreasing over a time, or it we have to check it is statistically significant or not. But remember, the Mann-Kendall test does not assess the magnitude of change. That's why there is other technique. It's called Shen slope. So in this workshop, I'll show you also how we can calculate magnitude of change. Mann-Kendall test basically detect the trend as the upper trend or lower trend, or we can call it negative trend or positive trend, and Shen slope detect the magnitude of trend upon the time. So it's the absolute measures. Okay, it's not a relative measure, it's an absolute measure. Shen slope is a absolute measures, so not a relative measures. That's mean it's depend on unit. If your rainfall in mm, so it is mm per unit. Okay, per, I mean, mm per year, mm per month. Okay, so problem is that in Mann-Kendall test, it's a dependent on autocorrelation function. It's a influenced by autocorrelation function. That's why Hamilton Rho published one paper in 1998. It's called modified version of Mann-Kendall test. Okay, I'll show you this paper, modified version of Mann-Kendall test, Hamilton Rho, published in 1998, Journal of Hydrology. A modified Mann-Kendall test for autocorrelated data. Okay, if it is autocorrelated, then we have to calculate modified Mann-Kendall test instead of Mann-Kendall test. Okay, one question in chat box. ISO test is also deciding the trend whether it is significant or not. Then how Mann-Kendall test is defined from ISO test? Definitely ISO test also a trend statistics, but Mann-Kendall test and ISO test is much difference, because ISO test basically is a linear regression method, right? So that's why Mann-Kendall test is not dependent on only linear regression. That's the differences. There is a different approaches to detect trend. You have to compare. We have to decide which trend statistics is better for your data, which trend is fit for your analysis. Like if you considered, sometimes what happen, you're working on pan evaporation data. Okay, if you use Mann-Kendall test, or some of you use groundwater data, also he use Mann-Kendall test. Sometimes it's not work because there's a problem in the assumption. What's the assumption? See, if we read this abstract, then you can know the negative part of Mann-Kendall test. That's a many positive part of Mann-Kendall test. Just we have to know the negative part. Null hypothesis of Mann-Kendall test is that data are independent. It's the most important part. That's when data are not serially correlated. Data are independent. Okay, so we have to check data are independent or not. Then independent and randomly ordered. However, existing positive correlation in the data increase the probability of detecting trend when actually not exist. If it is correlated, then your data shows there is a trend, but actually there is no trend. That's why Hamilton Rho in 1998, they proposed this method, modified version of Mann-Kendall test, and they use this ANIMA technique to detect this trend. Okay, if you check here, original version of Mann-Kendall test, first Kendall in 1955 and Mann 1945 proposed this method. This is simple formula, rank correlation test for two set observation. If you consider two set observation, or another thing, if you considered one set observation upon a time, then we can consider it's a time series data. That's mean in case of we replace this one set of observation by time. That's mean x-axis our time and y-axis our variable. So in case of time series data, we should follow this technique. We should follow this formula. Okay. So what is this? S mean what? Summation of Aij multiplied with Bij. Aij mean what? It is only considered when two set of variable, but in case of time series data, we have only one set of variable. So we have to consider this technique. S is equal to summation Aij equal to summation sin xj minus xij. Okay. Also, Kendall proposed another technique how we can calculate significance of 10. Okay, that's mean how we can calculate Z statistics. We can easily calculate Z statistics as divided by variable s. Variable s mean here n mean number n minus 1, then multiply by 2n plus 5 divided by 18. This is the formula. Okay, we can use this technique. Okay, and I have prepared one code, R code, for calculating this Mann-Kendall and modified Mann-Kendall test. And when you use Mann-Kendall and when we use modified Mann-Kendall test, that's why we have to calculate autocorrelation function, in short ACF test. Then we can decide it is this data fit for Mann-Kendall test, or is this data fit for modified version of Mann-Kendall test. Okay, so that's why other technique already I have mentioned, other technique proposed like innovative trend analysis. Main advances on the innovative trend analysis, it's a graphical method. So Mann-Kendall test, modified Mann-Kendall test, or Spearman Rho test, these all are a monotonic trend. We'll get only one value. We can say it is a increasing trend, we can say it is a decreasing trend, but we can't say about the sub trend, about the hidden trend. But using this trend analysis, innovative trend analysis, we can easily say there is any sub trend exist or not. If we see here, and also this method is not dependent on any assumption like serial correlation, like normality distribution, like sample number. Instead of that, we can also calculate low, medium, and high data. Okay, and in case of Mann-Kendall test, modified Mann-Kendall test, Spearman Rho test, it's also affected the data. Like if there is a outlier in our data set, definitely our result will be affected. But in case of innovative trend analysis, this result will not be affected by extreme values. If you see here, there is extreme values in this station. Okay, this is, I have taken this example from my published paper. So it's extreme values. So it's an outlier. Okay, but it is not affected the overall performance of this trend analysis. So we can say it is a monotonic trend. It's only increasing trend, right? This is a Cartesian coordinate system, 2D Cartesian coordinate system, right? And see here, in x-axis, this is the first half. So we have to divide it, our data series, into two half. Here, first half and second half. We have to divide it in equal part. If you have data series odd number, then you have to delete one from your data set, right? So see, this is a first half, 0 to 300, and here also 0 to 300. We have to take similar extreme values, 300, here also 300. Okay, then we have to draw it instead of x and y. X always we take first half. You can also consider the second half in here and first have been here, then we have to change it. This increasing 10, and this triangle falls decreasing 10. And this red color shows this red color 1:1 line. That's been no 10. If this point, this scatter point falls on this line, then there is a no trend. It's mean there is a no trend. If this scatter point falls this upper triangle, then we can say increasing 10. Or if it is falls in lower triangle, then you can say it's a decreasing 10. So here we can easily say it's a monotonic 10, monotonic increasing 10. But in case here there is a non-monotonic 10. How we can say? Because in the lower part, this is called low, this called medium, and this called high. Okay, there's a pattern in every data series. If we call it, see here's a one pattern, low, then another pattern, medium, then another pattern, high. Okay, all are increasing 10. But if we divided this data series into 3, like here one pattern, okay, low, then it is increasing 10, then medium, it is decreasing 10, then others, it is a decreasing 10, but it's a very high decreasing 10. So we can categorize using this trend analysis, using this innovative trend analysis by monotonic 10, non-monotonic 10, monotonic increasing 10, monotonic decreasing 10. Okay, so we can easily find sub 10 or hidden 10 using this 10 analysis. So Zakiya Sen in 2012 proposed this method, and now it is a very popular method for detecting any time series data. Satikiran ma'am asks, in ITA we separate our data into two halves, then we take only 36 years of precipitation data. Data means how can we separate this? Is this correct or no? Actually, I'll show you everything. Okay, you asked me this question, but I'll show you how can we do it, because it's a workshop, it's not lecture based. I'll not give you lecture what I have done. I'll give you how I have done. Okay, not what I have done. So I'll share everything. Don't worry about it. Maybe your experience is different in other workshop. Maybe they share only what they done. But my motto is how I have done it in my research. I'll share. Okay. And if you have any queries, you can ask, you can stop me, but it's better to ask in voice mode. You can easily unmute yourself. You have right to unmute. Okay. So let's share. You're feeling bored, like everybody in silent mode? I think you all are feeling bored.
No, sir.
I am feeling bored because I am talking to my computer. No, you can ask anything. We can exchange our knowledge, right? Then it will be two-way process. Other way it is a one-way process, right? Okay, no issue, no issue. So trend analysis, I'll share some paper I have published. Actually, I'll share my publication. Already I have mentioned yesterday, published this paper, investigation spatiotemporal variability. Actually, temporal mean trend analysis, spatial mean spatial variation. So we have to use GIS. Okay, if organize invite me again, then I'll obviously share how we can spatially distribute our result, okay, using GIS technique. Okay, so it was published from Arabian Journal of Geoscience. See here, a 15 paper, right? I have published 15 papers using MK, MMK, and ITA method. Okay, I have shown here only using this technique. So I hope everybody can publish. So I'll share first in your chat box. Ashit sir asks excellent question. Yes, say about monotonic 10 and non-monotonic 10. Yes, it's a very good question. Let me share first this file. Okay, please download these two papers also. Jacquesson proposed innovative 10 analysis, innovative 10 method analysis methodology. This is a technical note. Okay, Jacquesson, first time in 2012, right? He described everything, how he prepared this method. And this paper published from American Society of Civil Engineers. Okay. So it's much relevant with this department because civil engineering department organized this workshop, right? Now see, I'll explain what is monotonic 10 and what is non-monotonic 10. First, see this picture. The first graph. What I say, this line is a 45-degree angle, right? We can say 1:1 line. We can say no 10 line. We can say 10-less line, whatever you may call. Now, if our data point fall on this point, then we can say there is a no tint. We can say this is a 10-less time series data. If data point falls upper triangle, then you can say it's increasing 10. If data point falls here, this triangle, then it is a decreasing 10. But in reality, is it possible? Answer is, it is not possible in every time. Sometimes it may be happen like this. Sometimes it may be happen like this also. See this one. This is a decreasing 10. Obviously, this is a decreasing 10. Then it is increasing 10. In another case, it is a increasing 10, then decreasing 10. Now, see, time series having non-monotonic 10. If your data series has one tendency, if it is increasing, then monotonic. If it is increasing, then monotonic. If it is not a same trend, then it is called non-monotonic trend. In this time series, there is two types of trend: decreasing and increasing, increasing and decreasing. That's why it's called time series halves with non-monotonic trend, increasing and decreasing. Okay, so what happened in Mann-Kendall test or modified Mann-Kendall test or Spearman Rho? We get one value. It shows positive or negative. So that's mean we get either increasing or decreasing 10. That's mean it's a monotonic 10 only. But using innovative 10 analysis, we can say there's a monotonic 10, non-monotonic 10. Okay, and I have used this technique here, probably here. I have prepared one table, monotonic, non-monotonic. Not in this paper. No, in other paper, maybe in other paper. I forget in which paper I have used this technique. Monotonic 10, non-monotonic 10, monotonic increasing, monotonic decreasing. Okay, I forget it, but we can use it. Now, see, I have shared this paper. Please download it. Now, see this low, medium, and high. Okay, so how we can decide it's a low, it's a medium, it's a high? We have to see this pattern. You have to see this distribution pattern. This distribution pattern, and this a different distribution pattern. and this is another different distribution pattern. Okay, like we can easily select low, medium, high. Okay, and we can also categorize our result like low, medium, high. Low, suppose in this case, low, increasing trend, medium, no trend, because it's a haphazardly distributed. This is a decreasing trend, high decreasing trend. So we can prepare our result like this way also. One monotonic trend. It may be increasing or it may be decreasing. So monotonic increasing trend. Then monotonic decreasing trend. Then non-monotonic increasing trend. Then non-monotonic decreasing trend. Another way you can classify like low, medium, and high. We have to check there is any trend. We can say low is monotonic trend, monotonic increasing trend. And medium is okay, another will be no trend. On that example, low non-monotonic increasing trend, medium no trend, and in case of high is a monotonic decreasing trend. Monotonic decreasing trend. Should be monotonic. Okay, so we can classify it like this way: monotonic, low, medium, high, monotonic increasing trend, medium, no trend, and high monotonic decreasing trend. We can also categorize our time series into 3 parts. Okay, so now let's check it in Excel how we can divide it. Shati ma'am already asked how we can divide it our time series data. So here are annual data. So I'll use this annual data, right? See this count. Count is 37. That's when it's an odd number. So we have to delete 1, right? You can delete from earlier, it will be better. Then it will be from 1980 to 2015. And I have written here how you can prepare it, how you can draw it. You have to divide your given time series into 2 equal subseries, sort the subseries into ascending order. Then we have to plot it. Then we have to render the scatter graph to have the same length. Okay, then you have to draw 1:1 line. That's in 45-degree straight line. Okay, so let's do it in Excel. We can easily do it. So we have to delete first one. So
Sir, that 37 is total. You check, I think 36 only is already there.
37 total. So we have to consider 36.
No, sir,
In,
that's
okay,
37th row.
okay. Yeah. Yes, right. It's not the right thing. Yeah. We have to delete this. Right, you're right. So our data set here, but problem is that there is a missing data. So we have to take average. If you use it, it's called single imputation method, but it is my recommendation, use multiple imputation method. So annual data mean accumulate data, accumulate of 12 months. So we have to use sum function here. Sum of 12 month rainfall mean annual rainfall. So it's a annual rainfall. Now we have to divide it into two parts. Better to copy in another sheet. So here, just paste as a value. I'll name it ITA. Annual. Okay. Now, first half, total 36. It is okay. Then we have to consider second half. See here 18. Control X. You can see here 18. And paste here. Two equal part. We can say first half. And this is a second half. Right? Now, next part is we have to arrange it, select it, and here short, and here short smallest to largest. That's in ascending order. But remember, it's most important, continue with the current selection. We have to select continue with the current selection because we have to arrange it in ascending order independently. That's why we have to select this, continue with the current selection. Just select short. Okay. Again, select it. And short, smallest to largest, continue with current selection. Right. Now, select this. Our first half. First half mean what? We can say from it is sheet 4 probably 1979 to 2014. 1979, 1978, 1980. Nine nine seven, 998, right? So it's a year. Year. Just select this first half and second half, and go to insert button. Just select the scatter plot. This one, insert scattered. It's a scatter diagram. Select this 2D scatter diagram. Only 2D. Okay. Select it. Okay, so we have to change this orientation to 2D Cartesian coordinate system like this. Okay. Highest value 4123. So it is okay. 450, but here it should be same. We have to change it. Now we have to draw here 1:1 line. How we can draw it 1:1 line? We can easily draw it 1:1 line by a technique. It's 0. So lower value 0. Upper value here 4500. So you can say here 4500. Okay. Now select this data, right click, select data, and add data set. 10th line or 10 less line. Series x-axis, select it 0 to this value. Y-axis should be same and click it OK and OK. Now see here 2 point, select this and here you can find fill and line. Then here no line, select solid line. Now solid line, you can change this color. Okay, I want to give red color. Right, you can change line thickness. That's in width. You can change dash type. Okay, and this here is called marker. It's called a marker. So just select none. Okay. Select it. Marker option, none. Now select again this axis, this is a vertical axis, maximum 5,4500. Okay, select x-axis 4500. So here major and minor, here 1000, you can change to 500. Here also you can change 500. Or you can do another thing. For better visibility, you can change to 5,000 and change here 1,000. Okay, just change it here. 4500, you can 6,000, no issue. Now see this plus sign chart element, draw here is a axis title. Click on it and it's a first half. So give name first half. From 1979, right? 79 to 96. It's a second half. (1997) to 2014. we can do another thing. This alignment, we can change this alignment to horizontal. Level. Then find one option. Horizontal axis across. No. They don't have option. Level orientation, level position. I know. Next to axis. But we can change this orientation, right? We can change this orientation. We can increase size. But you should increase this font size at least 14, otherwise it will be not visible in your published paper. Figure should be small, no issue. But issue your font size. If you already published some papers, then you already aware about it. Now select this plotting area. Now go to border. You can give any border like this. Select, change it. Then again select this solid line. Select x-axis solid line. Okay. Again select it. See here fill, solid fill. You can change this color like, okay. Select this line. This is shadow line. So we can change this color to, yeah. Now select this marker and go to this option, fill and line, select marker, then again marker option, then again built in, we can increase size in default in 5. So we can increase according to our need. 10 is not good. So I think 9. No, it's overlap. Yeah, 8 is visible. Now it's look like good. Now select it again. You can change color according to your choice, according to your data type. It's a rainfall data. That's why I want to give color like dark blue, and border, one solid border like black. Okay, that's visible. Now select it again here, border solid line. It's okay. Select it again. Now change this color font, automatic color. Another important thing, you have to assign here name. Okay, so insert, you can take shape, text file. Suppose it is station A or any station name. Okay. Now, again, another important part, legend. See, it's called, as if it's called as if you change it here, then it will be changed from here also. Data point. Here one 10 less line and data point. Sorry. Select it. And we can place it any suitable place. Suppose here. And we have to draw one 10 less line here. Like we can easily draw it using shape. Here the line. We can draw here one line. Now go to here, solid line. Now choose color, same color like this, red with 2, because it is 2. And dash type, same, this one. So this is a 10 less line. Data point, 10 less line. Now it's a increasing trend, it's a decreasing trend. Similarly, we can draw it. Text. Increasing triangle. You can copy this one also. Control V. Just place it here. Decreasing. Yeah. You can format this level shape fill, like you can, if you want to use this white color for better visibility. Format background white. Now, just select all. Select one by one element. Main element is there. Select one. Press Ctrl button. Then select next one. No, you have to select Shift button. Select this. This line. Select this. Now, format. We can make a group. Now make it group. Yeah, now it is group. No. No, we have to make group. Again, select it. Select this. Select this also. Yeah. Go to format. Ungroup first, then regroup. Now copy it. Go to PowerPoint. PowerPoint is the most powerful tool. We can do it many things here. Paste as a picture. No, it's not shared. So we can do an select all. Copy. No. Now go to Excel, PowerPoint, and paste as a picture. See, now we can categorize trend, like it is a low train, it is a medium train, and has a high train. So insert, shift, can select this oval. I think it will work. No. Instead of oval, let's check other option. Many option is there. Now go to the shape fill. None. Then here color, red. Again, this one. Now we can copy it. This oval. It's a time-taking job. We can change this orientation, or we can change this size also. Right? Just change this orientation and should not overlap each other. And paste again, shift button and select. And now you can export it as an image. If we select it, change picture. No, not change picture. Select it, save as picture. We can save it in many options, save as type PNG, TIFF, JPG, your choice. You can save it. ITA graph. Like practice, ITA graph. This line is not exist here, right? So we have to do one thing. We have to also select this line. Yeah, then we have to, sorry, it's not selecting. Yeah. Yeah. We can make group from here also, like in format, then group, then we can easily export it. Saves ITA graph 2. We can say it's a low, medium, and high. Same as proposed by Jakiashin in 2012. After that, in 2016, Jacquier proposed magnitude of slope. In 2012, he didn't suggest any magnitude of slope. He just suggests about if it is closed to this line, then magnitude is less. If it is far this line, then magnitude is high. So it's a qualitative, it's not quantitative. But in 2016, he suggests one technique. Instead of change slope, he suggests one technique because innovative trend analysis is just replacement of Mann-Kendall test. Okay, Mann-Kendall test is a 10 direction test. It's not calculate any magnitude. But in 2016, he compared with the change slope. So if we see in this paper published from Hydrological Science Journal, I have also published one paper from the journal, Hydrological Science Journal. Hydrological trend analysis with innovative trend and overweighting procedure. Just I'll show here how he calculated magnitude of slope. We generally call it S. Yeah, this formula. S mean what? 2 M2 minus M1 divided by N. N mean what? N mean the half length. See, N by 2. Okay. So if we did this one, innovative trend slope. In this work, the innovative trend slope, that's when S1 is calculated by the subtracting the second half of arithmetic average. So we have to calculate arithmetic average of second half from the first half. Okay. That's the M2 mean arithmetic average of second half, and this mean arithmetic average of first half divided N, then divided this difference by length, half length. That's mean N by 2. So this is the formula. Okay. I'll use this.
Repeat that one magnitude of slope.
Okay, just a minute. So this is our formula. S1 mean magnitude of slope. According to Jacquier in 2016, he calculate the magnitude of slope using this formula. What is magnitude of slope? What are the difference between 2012 and 2016? 2012, he proposed this method to compare with the Mann-Kendall test. Mann-Kendall test is only 10 direction technique. But with Mann-Kendall test, we know another technique that's called change slope analysis. Change slope generally measures what? Magnitude. That's mean change per time. Okay, changes over time. Okay, so in replacement of change slope, he proposed this method. So M2, M1. So we have to calculate here. This is first half. This first half mean M1. Second half mean M2. One question in chat box. This is another technique, overweighting. This is a data series problem. This is similar to the stationary or similar to the serial dependency. This is also another data series problem. we generally considered our data in normally distributed, but in reality, never any data normally distributed. We can't say it's normally distributed. Normally distributed mean what? Normally distributed mean mean, median, mode should be same. So in reality, we cannot get any types of data. Both mean, median will be same. So that's why all are overweighting. That's why we have to calculate ACF. So M1 and M2, but we can consider 5% confidence interval. So we overlook that portion. M1 and M2. So we have to calculate here average, arithmetic mean, AM. So in Excel, function called average here. So we have to select first cell to last cell and enter and drag it. Okay, now we can easily calculate our ITA slope or F. So first half, second half. So 2 multiplied within bracket average of second half minus average of first half, then divided by half of the series, in our case 18. So in our case, see 2193.372, here 2566.489. So here our change is 41 mm, positive value 41 mm per annum. So 41 mm per year. This is the formula. Okay. Now, problem is that if we want to compare with other method like Shen slope estimator or like Mann-Kendall test, so we have to consider other technique, and I have used this method also. I can see in my publication, I think I have written it clearly. Or maybe, let me check. Maybe here. See, I have used different methods. Right here, slope of ITA, following equation. Why? 10 instead of 2, I have used a 10. Xj minus xk means same. Xj mean second subspace, xk mean first subspace, and say x bar mean average. X bar mean here average of first subseries. Then this is summation. Okay, summation 1 upon n. So I have used this one. Why? Because for if we compare with Mann-Kendall test, is suggested by another researcher. I forget the name of this researcher, but I can share this paper. I have this paper. I have to check it. This paper also published from a very good journal. And if you use this technique, this method. B value is all are same. This is xj, xk, so we can say this is a xk, this is a xj. Now, first one, xj minus xk, xj minus xk multiplied by 10 within bracket 10. Okay. Divided by average of first half. Average of first half. Right. Okay, we have to fix this. Sorry, we have to fix this. This cell function F4. Okay. Now summation of it. So sum then divided by 1 by n, that's the number here 36, 0.850. That's the difference of two techniques. So this is my recommendation. You should use this technique to compare with chain slope. Okay, I'll show you what value we'll get when you calculate using the chain slope technique. Any question? No question. So I can move forward to our next task. So that's it about ITA. Now I'll use same data set for calculating Mann-Kendall test, modified Mann-Kendall test, right? Up to here. Okay. You can name here any station name or anything. And suppose station 1. Just save it, go to file, save as, my computer, live practice, data for MK. So I'll use here R software. So R is a free and open source software. You can easily download it from their website. Just in Google, search ArcGIS. Then you'll find the comprehensive R archive network. You can download from here. If you Windows user, then download R for Windows. Okay, then there's a mini version. If you're first time using this R, then download this base version. Then download R, this is the latest version, R 4.2.1. This was 64-bit Just download it. It's about 75 MB. Already I have installed it. After download it, just right click over there and run it. It will take few minutes. Already you have downloaded this. Everybody here? I think it's too long, no? It's very difficult to everyone. So I'll share my code also.
Available in Anaconda? Sir, is it possible to use the R Studio available in Anaconda?
Yeah, you can use also RStudio. Original software is R. You can use also RStudio. So I have prepared one code for MK, MMK, and ACF test. I just share in your chat box. You can download from here. So after download it, you can install it very easily. Already it is downloaded. Now check it, show folder. Just right click and run as administrator. Okay. Already I have installed it. Now I can use it from here. Here my R. Then this one, original version of R. This is R console. We can delete everything from our console using Control L. Now here file, here a new script, source R code, open script. So I have prepared it in a text format, so I can copy and paste from here. I have shared this code with you. You can use it for your research. Just to one request, refer my paper in your manuscript. So this is a simple process in our software. You may be aware about it. We have to upload our data using this technique, data, read data.csv file. So if you are new, then it is very difficult to explain within this hour. So I have prepared it, just use it, nothing else, just select it. It's a very easy. Run this line of selection. Then I have saved it in my deep folder here. Then light practice, I think, yeah, data for MK. Select it. Now data 2, then it will delete time frame. Now data 2. See, there is a problem. Row name, okay. Let's check it. And this data. Data for MK. Better to save in CSV file, CSV comma delimited. Data to MK CSV. Again, go to R. Run selection. Data for MK. Then data 2. Then run selection. Here are data. Problem is here 36. Like practice data for CSV. This one, I have to delete this. No. We have to input our data again. This spacing. deep folder, live practice. Yeah, now everything is okay. So for ACF calculation, this function called, this tool called ACF selection. So this is ACF, okay, ACF lag 1. Why lag 1? We can calculate ACF in many lag. So it is a lag 1. Here in x-axis is a lag, and here autocorrelation function. What is autocorrelation? Autocorrelation actually detect the correlation exists among the time series data or a given period. Like I have considered here time series 1, that's when lag 1, because I have annual data. Okay, I have 1957, then 1958, then 1959, like these. So interval 1. That's why I have considered here lag 1. Okay, and this blue dotted line, see this blue dot line is a 95% confidence interval. Okay, if so, it is 0, and here this line shows highly correlated because this is 0. That's when T0 definitely it will be 1. That's when it's compared data itself. Okay, so it's a correlated 1. It should be 1. But in case of this say lag 1, lag 2, lag 3, lag 4, lag 5, lag 6, like this. So we'll consider lag 1. In case of lag 1, say this is 0.2. So probably this one 0.1 or 0.17. So it's not significant. Okay. See this p-value 0.41. So it's not significant. So we can consider here data is not serially dependent, or there is no stationary problem. Ratna Kumarji asks there is any stationary problem, how we can detect it. So this data is not stationary problem. Okay, if it is beyond this line, then we can consider it, no, it's a stationary problem. We have to calculate modified Mann-Kendall test instead of Mann-Kendall test, right? Now, so we can calculate it. So I have prepared this code. You can calculate both Mann-Kendall or modified Mann-Kendall, everything in one time. Just select it and run this line selection. See, just ignore now modified Mann-Kendall test because we already know modified Mann-Kendall test is not needed for this purpose because it is not a stationary data. There is no problem of serial dependency. So we'll consider Mann-Kendall test. Now Z value. Okay. So here Z value 2.35. 2.35 means what? So if Z value 1.96, more than 1.96, then it is 95% significant level. If it is 2.578, then it is 99% significant level. If we want to consider 90%, then it is 1.68. Okay, you can find Z statistics. You can also calculate it from Excel. I have a YouTube tutorial. You can watch my YouTube tutorial also. Now, you can see here also this value, P value. Okay, ZM 2.35. If you don't know about the threshold value of Z, like 1.96 equal or more than 1.96 when 95% confidence interval, you can say from here also 0.018. It is 95 confidence interval, but it is not 99% confidence interval because it's p-value 0.081. If p-value more less than 0.05, if p-value less than 0.05, then it is 95% confidence interval. If it is less than 0.01, then it is 99% confidence interval. Simple method. Like this is a candle tau, we know the correlation of candle tau, and it's a Shane slope. Now see, Shane slope in this case 20. 20 mean what? 20 mean 20 mm per year. Now already we have calculated using our method to Z value 2.35. I've closed this. So Z statistics 2.35, right? And Shane slope 20.04. mm per year. If p value less than 0.05, then it is significant at 95% confidence interval, or if the statistics more than 1.96, then it is significant at 95% confidence interval. So we can consider both. Okay. Daily to monthly. ITA. Now see, according to original method of Shane, it was 44 mm per year. But according to Shane slope, it is 20.4 mm per year. Okay. Now, J statistics is a significant increasing trend. We can say it's a significant increasing trend. If you see this diagram, yes, it is a significant increasing trend. It's an increasing trend. We can't say it's a significant or not significant, but we can say it's a increasing trend. It's a monotonic trend. If you see any series monotonic trend, then we can say it's a yes, it's a significant. Okay. So problem is that these all methods are absolute measures. That's why I have proposed one method. It's called percent bias. Okay, but unfortunately, it's not focused widely. But I have proposed it and name it as a percent bias, and we can easily calculate it. In this study, in order to estimate percent change in rainfall between first half and second half of time series, the percent bias method was used the following formula. Okay, Mondol et al. This also our paper. We have published in the first in a book series. This paper. Rainfall insight in Bangladesh and India. Climate change and environmental perspective. So this is called percent bias. New technique they proposed in 2020. You can use it. You can also modify it. What's the new thing in this method? New thing is that it's a relative measures. It's not a absolute measures. You can compare temperature to rainfall. Using change slope, you cannot compare with rainfall and temperature. You cannot compare rainfall to wind speed. But using this method, you can easily calculate it. Simple formula. 100 minus summation. What summation? What? Y1. Y1 mean second half, average of second half divided by average of first half multiplied by 100. This is the formula. So just 1 minute. So already I have calculated average of first half and second half. Though, so formula is P bias equal to 100 minus average of second half divided by average of first half multiplied by 100. Second half. D22 and C22. Just a minute. $107. You can use here 100 here. So 17. Okay. So that's mean changes over time 70%. 17% changes. Right. So guys, I hope I have finished every task and also describe other things. I hope you can use this technique in your research. You can publish some good paper. If you want to collaborate with me also, you can contact with me. And here my phone number, WhatsApp number and mail ID. You can contact with me anytime by WhatsApp and mail. And also I have a small YouTube channel. So let's share it. I think this is my YouTube channel, Dr.JayantaDas. So you can watch some video from here also. Always I upload here. And we have a small academy. You may love to join this academy as an expert, as a mentor, or as a participant. We have lots of courses. Not lots of courses. We have only 6 or 7 courses, but some flood hazard, groundwater, and also drought vulnerability, landslide, morphometric, rainfall indices, LOLC mapping. Okay, so you may interest also to join this workshop. So up to here today, if you have any query, any question, you can ask. Shobhan sir,
Yes, sir. Yes, sir.
over to you.
Yes, sir.
I have completed the task, so
Thank-
if
thank you.
you have any question, I would like to answer them.
Thank you so much, sir, for your.
One, let me tell
Yes,
you
sir.
something here.
Yes, sir. You can say.
Am I audible?
Yeah, yeah.
Yeah, thank you, Dr. JayantaDas, for the. I can say that I explained the information what you have shared for the beginner, right?
Yeah, yeah.
Because even though we are in the same field, I have enjoyed. I have seen a few of the things. Then I have discussed with the someone also that how nicely you are presenting, and throughout the session, probably some of the participants they're asking the query. They're very that what I can tell that excitement, and more few that in the near future also we will organize in the various the activities. Probably collaboratively we will do some work.
Yeah, sir. Sure. Thank you.
Yeah,
Thank you.
from my point, that is whatever the work is going on in that Centurion University, that collaboratively we will work on that.
Okay, surely, sir.
I will tell to Shobhan will discuss with you.
Okay, surely, sir.
Yeah, thank you.
It is also nice experience for me also. There's lots of participants, near about 66. So it's a very good from.
Sir, we also got participants from NIT and IITs. I
Okay.
think the speaker role was very important for this workshop.
Yeah. Yes, yes, we have seen that. Then various other
Government organizations.
yeah, the community organizations they are coming also.
I am very much thankful to Jan sir, because from the last 4 days we are suffering from fever, but still
Yeah.
he managed to cooperate with us for the 3 hours. I didn't expect he will continue till 5 p.m.
Yeah, yes.
Extremely sorry.
It is
We
very
wish you that-
difficult, but
Wish you that speed. Wish you that speed recovery. Get well soon.
Yeah, thank you, sir.
Extremely sorry for
No
disturbing.
issue, sir. No issue, sir.
But it was a very nice informative session. The way slowly you managed to tell everything, because mostly what happens, people expect that PPTs will go on. Mostly they expect PPTs will go on and they won't be able to understand. But I hope the participants have enjoyed those Excel files. Real time working practical session, the way we have narrated that it will be a practical session. Thank you, sir, for doing it so nicely.
Thank you.
And I also thank all the participants for their patience and effort and cooperation in joining today's workshop.
Let us close that before closing. Then please ask every participant. They have to switch on. So take some of the photograph. Okay.
Sir, can I ask the last question? One last.
Yeah, please, sir.
Yes, please.
So it's not a technical one. Sir, whenever we are writing paper, we have to quote all these methods. So we will be writing the equations and everything. So in plagiarism, they are getting identified as that means repetition. So sometimes because of that, this plagiarism limit is going beyond 20%, 15%. So how to manage this? Because without quoting, we cannot write a paper.
No, you can easily manage it. Just see this, my paper I have explained here. See, in case of original paper, they have written SGN. SGN mean what? Sign. So I have written here SIGN, similar thing.
Okay.
Sometimes
Okay.
they use what? They use X1, X2, X3. For avoiding plagiarism, I have used here YK. That's it.
Okay.
So you have to change
Okay.
similar thing is similar. Okay. If you change it this one, then everything will be changed. Plagiarism should be less than 15%.
Yeah. Okay, sir. Thank you.
Thank you, sir.
Any other question? No.
Sir, innovative trend analysis and modified innovative trend analysis. Sir, just say the 2-3 lines, the basic difference.
Innovative
Inno-
and modified innovative. Actually, there's no method called modified innovative.
there is some paper, sir.
Maybe someone modify it. Zakier use another method. This is not in our program today because I have to read it. Probably one of modify it. You can also modify the innovative trend analysis. You can name it another thing. Okay. But it is not popular, I think.
Okay, sir.
So what to popular, sir?
Yes. Shravan,
Yes, sir.
yeah, please take some of the snaps and bind off, right?
Thank you, sir.
All of you, please switch on your video. Arvind, what happened?
You should take the snapshot like this.
Yeah, take like this. Yeah, please. Take like this.
Thank you so much, sir, for your effort and patience.
Thank you.
We'll be working in future.
Okay. Sure. Okay. Thank you,
Thank
sir.
you so much, everyone, for joining this workshop. We'll be having many more future endeavors, and we'll be in touch with Jayanta sir. And anyone who is interested, like sir has given his WhatsApp number and his mail ID, so you can communicate with sir. And we'll be having that WhatsApp with no problem. We can share our problems, we can share our queries, and if anyone is available, he can give some solutions to the queries.
Sure.
Thank you so much, sir. Thank you, everyone.